So, good evening, everyone. So, welcome to week 9 of the live discussion sessions for the course Foundations of R Software. So, this week's contents were mostly focused on strings and string operations or built in functions in R that you can use to conduct certain operations on strings. Now, normally, if you're working with a very low level language such as C, then you won't get these facilities. So, for example, in a language like C, you have numbers, you have booleans, but you are only limited up to characters. So, there to define a string or to manipulate a string, you have to write a lot of code. In mid-level languages like Java, there is a lot of functionality built in which you can use to manipulate strings. But for languages like Python and R, so almost anything that you can think of doing with a string or with a collection of strings, that can be done using built-in functions. So that was the focus of this week's lectures, and that is what we are going to revise. But in addition to that, if you have any doubts on basically printing strings or splitting strings, counting the characters in a strings, any of those topics that were discussed this week, you can feel free to ask. So I'll start by sharing my screen, and please let me know if you can see the screen and also if I'm audible. Hopefully everyone can see the RStudio window. Now, in case at any point of time I'm inaudible or if my screen gets frozen, you can unmute yourself and let me know, or you can write it in the chat. Or in any case, there is no need to panic because anyways the recording of the full session goes on YouTube. So even if my internet stops functioning properly, whatever I'm doing will still get recorded. Okay, so the most basic operation that we can do with any result, whether it's a string or a number, is basically printing that result. And we have this simple command which is named exactly based on what it does, called print. We've seen that we can use this to print the result of calculations, print simple numbers, print even some collection of characters, which is basically what we refer to as string. We can also print vectors. So all sorts of operations are possible. So for variables, if you give it a name, it will think that that's the name of a variable. So immediately it will start looking for those values. So if I say x equals 5 and then I say print 5, print x, then that works fine. But if I just say print y, that may create a problem. So whatever you want to print, either you put it in double quotes or you store that value in a variable, then the print statement is able to do that. But there is a limitation of the print statement. So if I'm writing a long sentence, like this is a long sentence for demonstrating print function. Now, you can write an entire paragraph inside print, and that works fine. But sometimes you have consecutive calls to this function. So instead of writing this long sentence, maybe you have something like print ABC followed by print DEF, and then print, let's say, LMN. Now notice the presence of semicolons. So that means that this is one statement, this is another statement, this is a third statement, but all three statements have been written on the same line on the console. Now when I execute this, what happens is print is being called 3 times and the result is also printed separately. So now if we want them to be joined together, something like this. So this construct of defining something or defining a collection of things inside print which are separated by comma. Now in many programming languages, so for example in Python, if you do something like this, it will automatically join these three strings together. But if you do it here, see, this sort of creates a problem, and this is not good, especially when we want to add a variable here. So let's say, as an example, let's define a date, d equals date. So if you remember from last time, not last time, but from a couple of weeks ago, if you just call this date function without any argument, it returns the current date and time. So we have stored that in the variable d, and suppose I want to print on, or let's say on the date and this date d, and I want to say I will be X years old. So now why I may encounter something like this is because, again, when we are running a program, we are not always working with constants. So during the course of a program, things change, and sometimes that is reflected in the output as well. So if I give something like this, the expectation was it will say something like on the date and then mention the date, I will be 5 years old. But that is beyond the functionality of print. So this is something to keep in mind, that from your experience of other languages, you may expect print to behave the way it behaves in those languages, especially. So there is a lot of overlap between R and Python, but the reason I'm mentioning this is because just like R is used for statistical analysis a lot, Python is also very popular in data science. So there may be overlap in the course of your work, or there may be situations where you have to call Python from R or you have to call R from Python. So in those cases, it is useful to remember, even though some functions have the same names across different languages, they may not behave the same way. So what we can use instead of print is something called cat. Now this behaves in the desired way. So on the date, and this date, I will be 5 years old. So cat is basically short for concatenation. So cat is short for concat, and concat is short for concatenation, which is nothing but the joining together of two strings. So again, just like you can do 3 plus 2 as 5, normally this is also something known as function overloading. So we know that plus is a symbol for addition. In some languages, when you do plus between two strings, what it does is it joins them together. So that's the meaning of concatenation. So you take the first string, and at the end of that string you take the other one and join them together to form a new string. So what cat is doing is automatically, so it's taking the first string, which is made up of these three words with two spaces in between. Then there is a variable. So you note that the variable is not actually, so this is a date, but when it is printing, it's actually getting printed as part of the string. So a conversion is involved. Then there is another string, then there is a number involved. That number also gets converted to a string, and then this last string. So you have given it a collection of strings, dates, and numbers, but what it is doing, it's converting everything to a string, joining them together, and then printing the output. Another thing that you can note is we had not given any space after date or after B or before years. But here in the output, the spaces are put exactly where there are commas. So why that happens is something we can see by looking at the definition for cat. So let's look for cat. So you see, the definition says that normally you keep some string or collection of strings here, or any collection of objects. So you can also give cat 3, 2. It will just print 3 and 2. So then there is an option to give some file name. So sometimes you don't want to print on the console because let's say the result of your calculation, so you are using this cat at the very end to declare something, I mean at the end of your script or at the end of your program, and that is something you don't want to display on the console, but you actually want to store the results in a file. So that provision is also here. You can give a file name. So this is a bit complicated, we won't go into file operations here. Then this argument, SEP, this is what determines how we are separating the different strings. Like I said, there is a comma, then the other variable, the comma, then the other string, again another variable, another string. So by default, the value of SEP is just a single space. That's why we are seeing spaces here. If we do the same thing, let's say 3 and 2, and say a separation, I want to put a star in between, or if I say I just want to put 3 dashes. So this is what this SEP argument does. Now there are some other options as well. So there's a fill, there's labels. You can give labels to if you're doing a multi-line operation. So, and lastly there is append, which basically works if you are doing a file operation. Now if you compare this to the definition for print, you see, you can print an object of a given type, but the other arguments basically depend on what kind of type you are working with. But there is no SEP or there is no file operation or anything like that. So in that regard, print differs from cat. Now, what we have seen so far is the application of cat on, atomic objects made up of one type of, or you can call them scalar. You can call string as a vector of characters, but you can also store string in a single variable. So we'll just refer to it as an atomic variable. So this is one variable, this is another variable. Each of them is storing one value. But you can equally well apply cat on vectors. And let's say if I just say cat 1 to 50, it will just print from 1 to 50. But the good thing is, even here I can actually give a separator. So let's say I want to separate these numbers by plus signs. So you see, so these are the kind of manipulations that we can do with cat. So let's say we define x equals let's say 1 to 5, and then as a demonstration of the abilities of cat, you can take x, you can say fill equals 2, which basically shows you how many items will be in each line, and as labels, so basically for each output that gets printed, if I don't do labels, I'll just print each of them in a separate line. But if I do something like labels equals, and we have brought back the paste command, which is something we'll also go into the details of. But we have encountered paste before. We've seen that it joins together strings. So what we want is to show these letters, and we put another box here. So you see, the string that you constructed using this paste command. So you put an opening bracket, you use letters from 1 to 5, you put a closing bracket and a colon. So now notice that my input is a vector, or the object I'm working on is a vector. It contains 5 elements. The labels that I'm assigning is also letters, so first 5 letters. So a correspondence has been established. And when I print 1, I'll use the first letter enveloped between these parentheses and a colon as my label. And similarly for 2, 3, 4, 5. So we can always experiment with this. And let's say if I add more labels, let's say what happens then. This should work fine because I ran out of output, so those extra labels were never utilized. But what about the case when I give less labels? So you see, this is something maybe you can recall from earlier. So when we were trying to study matrices and we were trying to fill it with, so let's say we were working with a 4x5 matrix, which should have 20 elements. But if we provided only 10 elements or 15 elements, what R was doing, it was again starting from the beginning and trying to fill in the empty spaces. So similar operation is happening here. So I have 5 objects, but I have only created 3 labels. So it will go up to the third label and then start at the beginning. If I change this slightly, and then you see ABC, ABC, this gets repeated. So these are some of the manipulations that you can do with the cat function. Now, shifting our focus to the paste function. Now, one difference between cat and paste, even though both of them join strings together, is that the output of paste, so say if I write A equals paste, and I say hello world, and you see that value gets stored inside A. But what if I try to do the same with cat? So you see, even though the operation of cat is to print, so hello world got printed, but nothing got stored inside B. So that's why it's showing B equals null, because R is seeing that there is a declaration of this variable, but this guy only has a side effect of printing. It doesn't return any values. So that's why it's showing B equals null. So that's where paste is useful. So cat, you can use cat when you want to print, but when you just want to join 2 strings and add that value to, or store that value in a variable, then paste is your friend. So what I was trying to do earlier, of concatenating things, hello world, which did not work, that can actually be achieved using paste. So you can paste 2 strings, 3 strings. So say hello world, or you can then say a line break, and say goodbye. I just pasted everything together. Anyways, so Now paste also has some advanced features, just like cat. You can do a lot of manipulations there. So let's look at the definition. So of course you have to give some objects which will be converted to character vectors, or in other words to strings. And you can give a separator here as well. So by default it's an empty space. But what you can do is, put a star or minus sign or whatever as per your needs. Now collapse basically says whether you want to separate the results or combine the results. So how that works is that, let's work with some vectors. So let's say names equals, I'll just use very simple variable names, name1, name2, person3, human4. So I have a character vector. Now if I just do paste and give names as an argument, and then say the other string to be is late or was late. Yesterday. So working with vectors, it basically does the appending for each of them separately and returns a vector. And you can store that to a variable. Now you see where one is also a character vector. The first element, name1 was late yesterday, name2 was late yesterday, and so on. So basically it takes the first element and then adds this to that. Then it takes the second element, adds this to that. And in that manner it constructs a new vector. Now speaking of the collapse argument, so say var2, then I put collapse equals to. So what collapse actually means is, again, like you can see, this is a vector of strings. What collapse does is it combines these as well. So default setting of paste is to combine the first argument and the second argument, or however many arguments you give, basically comma separated strings. If that results in a vector of strings, like here, and you want to combine everything together, then you can use collapse. So let's say collapse, and we add and. Or maybe put a comma. So let's print var2 and see what was here. I think it's a better idea to put another space here. So this works something like this. So the entire contents of this first element, then this separator. So this separator is different from the SCP argument. So you can do two things. You can put an SCP and see the differences between the two cases. So let's say let's put a hyphen. Or maybe something like colon in a space. So that's where the difference lies. Maybe we can make it more complicated. So we already have names, then we define something called days. And then say Monday, Tuesday, Friday, and Sunday. This is days, and we'll define something called R3. So names was late on, we may or may not need to put this days, then comma, and let's put hyphen. So from the positioning of the hyphens, you can see how the SCP argument works. It just adds a separator between the strings that you are providing. So you get one string from the first element of names, which is name1, was late on, was already there. Then you pick one string from the first element of days. So that was Monday. There's a hyphen and a space, which we have added as separators. So name1, then hyphen and a space, was late on, then hyphen and a space, and Monday. Or maybe you can add another space. But this piece, comma, space, and space. So this is the result of providing value for the collapse argument. So if we had not collapsed this, in the absence of any collapse argument, this would have been a vector. So first element of this resulting vector picks the first element from this vector, appends or attaches or concatenates this string to it, and then picks the first element of this vector and attaches it to the end, with space hyphen space being the separator. Same thing is done for the rest of the elements of names and days. So corresponding elements are matched together. Now what we can check is what might happen if, say, days has less number of elements. So any guesses what may have happened here? And before I execute wherefore. We are using two strings, or two vectors of strings, but they are of unequal length. And there is one string which is in common, which will get appended to or concatenated to everything. And let's see what this does. So again, the usual R behavior. So one of the strings has less number of elements. So let's do this again. So names, let's modify names. Now just remove name1 and name2. And then redefine wherefore. So you see, no matter the order of the strings, if there is a mismatch in the number of elements, it just restarts from the beginning. So here we had seen when names still had 4 elements, but days has 3 elements. The first element of each of them is combined together, second element is combined together, third element is combined together. Now when it comes to the fourth element of names, there is no corresponding fourth element for days, so it goes back to the first element. Similarly, if names had a smaller number of elements, so like here, if this had only 2 elements and days had 3 elements, 1, 1, 2, 2, those are matched together. But for this guy, there is no companion, so this goes back to 1. So this is a general R behavior of filling in spaces by, traversing through the list or the vector from the beginning again. Okay, and as far as numbers are concerned, so if I write paste 9, if I write paste 1 to 9. So can anyone tell me? So I'll give you an incomplete question and I will ask you to complete the thought. So you can see I've given a number as an input. I can give many numbers as inputs, like here, but the output is coming out in double quotes. So can you tell me what is this equivalent to? So what function am I thinking of here? So as dot blank applied on 9 would give me this. So what is blank?
Character.
As dot character, yes, correct. So as dot character acting on 9 will do the same thing. As dot character acting on 1 to 99, that will also do the same thing. So if you check this, put it is dot character, it says true. So this is something we must remember. Conversion to string is straightforward and it is done all the time. But conversion to integers has to be done explicitly. So you have to explicitly say as dot integer if you want integers. Because the moment you put a number inside print or paste or cat or any of those functions, it gets converted into a string. So if you are storing the output of paste, even if paste returns a single number, if you are storing it in a variable and you try to do mathematical operations on that variable, then you may get errors. Okay, now we can maybe move on to the topic of splitting strings. So sometimes it happens that you are asking for user input. So let's say you have an interactive program, but you are asking a lot of information from the user, and your program wants to filter out what information to store inside what variable or how to segregate that. So let's say you are asking for a student's record. So what you're asking is something like, you're asking the marks obtained by the student. So let's restrict ourselves to a single subject. Now for that subject, you have one mid-semester examination and one end-semester examination. And let's say you had given the student 5 separate homework assignments. Each of them were graded. Now to compute the final grade, there are different weightages of these. So what you're asking the student is, first enter the student's name, then enter the student's roll number. So you know the sequence, your program knows the sequence. Now all it matters is that the student has to respect that sequence while entering the data. So name, roll number, then you want the marks obtained in each of the 5 homework assignments, then the marks obtained in the mid-semester, then the marks obtained in the end semester. So normally, what we do is we assume that student name will be 1 word or maybe 2 words. Then comes the roll number. So roll number is some sequence of numbers. And some marks, let's say out of 10 maybe for the homework. And some mark out of 50 for the mid-semester examination and something out of 100 for the end semester. Now if a student is entering a record like this, the moment this is read in by the system, this gets stored or let me make this first name. Last name. So the student is entering this data with the assumption that his name, first name, last name, that will be stored as string. Roll number may be a number, maybe a string, because you don't do any modifications on the roll number other than maybe sorting them. And the marks, he's entering them as numbers. But once this entire thing is read in by the computer or by the program, this entire line is converted into a string. So the entire line can be read in as a string. Now it's up to the program to separate out the contents of the string. Now we did not need a complicated example like this. We could have said something simpler also, that I just want name and roll number and I want to separate the two and store them in different variables. So that's where this strsplit, short for string split, is important. So what you have to mention here is where exactly are you splitting. So I'll say let's split whenever there is a space. Now can anyone tell me the type of the output of this strsplit? I mean, looking at what's printed here, can you tell me what kind of object this is?
Characters.
No, these three are characters, but the entire thing. So if I do, let's say, I take this full thing and say, I want to know the type of this. So what kind of container is this? Vector is a kind of container, array is a kind of container, matrix is a subset of array. So this is a list.
So I just want to ask one question. Like for example,
Yeah.
are case sensitive, like we use other software like SPSS one, right? Like between the first and the name,
Yeah.
if we keep space, that means that can create issues.
Yeah. So if you have, so whenever you are making interactive programs, of course you must leave some instructions for the user and also for the program. So one provision could be that you tell the user from beforehand that only enter your first and last name, don't put a middle name in between, or don't have separation. Another solution is you can allow the name to be as large as possible. So space may not be the best splitting tool. So what you can use is, let's say, a comma. And
Underscore?
you can, sorry?
Underscore?
You can use underscore as well, but you have to instruct your user that this is how you must separate your input. So now if I do 10, 8, 7, 9, 8, and then a comma, then maybe 43, comma, and 92. And now if I split using a comma, it doesn't matter if I have just a first name or last name, or first name, last name, middle name. So you see, this entire name is now one object. This whole thing is one object. Similarly, now of course there is a small problem, so I should have added a space here as well. Now it's fine. Now when you want to access individual elements, so usually when you write complicated programs, there is a sequence to the way things are happening and the way variables are being stored and further processed. So I'll just say, let's say student info, let's call it that. Let me clean this out. Now student info is a list which in a fixed order contains the full name, the roll number, all the marks obtained in all the homework assignments together, then the mid-semester marks and the end-semester marks. So using student info, you can define something like student name. So or let's just call it as name. We take student info, and you must remember, since we are working with lists, you have to access the sub list inside it first. So this double brackets 1 has to be there, and then you can put 1. So what is this name? So you have read in the entire content of your console. The whole thing was converted into strings. You had instructed your user to enter each of these quantities separated by commas and a single space. So that is what your program utilized to split these informations. And now based on this full information, you can do separation. So S name is this, S roll number would be this. Let's call this similarly as homework marks. Student info 3. Now if I do this, my job still is not done, because with the homework assignment marks, and also with the mid-semester and end semester marks, I want to calculate something at the end. So what is wrong here, or what is the nature of the incompleteness that I'm speaking about, or what is the problem with the current form of this s_hw variable? Anybody? So let's say I want to take the average of the homework assignment marks. Do you think that will work here? Let's see if that works or not. So I want mean of the homework marks. This did not work. So can anyone explain why not? Because my user can complain that he entered numbers, he entered the marks he had obtained, but in his report card, I'm saying that his grade is NA. So his average of homework marks is not available. So who is wrong? So is the program wrong at some place, or is the program incomplete, or it is the student who is telling a lie?
Maybe one of the characters is
not working.
Right. So this whole thing, so you, just in one single step you can check SHW, the entire thing is a character. So what we should have done is put this right as dot, it's a double. Then I introduce my coercion. Okay. Let's see. Okay, I guess this becomes a homework assignment for me. So, how to convert from a string to this whole thing. Or maybe there is another way we can work on this.
Maybe something like true, false, maybe using those
We can just
constants.
try to split this HW. So that way it should work. HW marks equals non-character argument. What is wrong here? So I've already stored it here. Why will this work? Let me. Okay, now we should be able to use this. Yeah, now this should work. So I unlist HW marks and then I can do this as dot integer or also as dot double. This is fine. So based on this small exercise, maybe you can see string manipulation is important and it can be a bit complicated at times. So not only the entire line itself was string, even the collections that we are picking up after splitting that line into different variables, there's still some strings inside it. That's why this strsplit is a very powerful function and very useful function. So using this strsplit, first we were able to, break down the entire console input or user input, and then within that input we are finally able to extract the homework marks as numbers. So I can put a mean on the front. I can just put a sum, and this can be cross-checked. So the sum should be what, 42 or 17, 7, 18, 42, and 42 divided by 5 is 8.4. So now, for demonstration purposes, we are doing all of this in a console, but of course, when you're writing a program, because ultimately you want these things to be, automated. You want them to.
Why in the first place are the marks in the as a character, right up there, like?
Sorry, I think my internet had gone for a moment. So can you repeat what you were saying?
I said, like, why in the first place the marks are stored as characters? So, like, they're 10 in double quotes, 8 in double quotes, 7 in double quotes. Why was it stored as character? In the initial.
Here.
Yes.
So that's one conversion which is happening. So R has no way of knowing R or any programming language for that matter has no way of knowing the user's intentions. So by default, what we have when we are printing to a console, we have something called the output stream. When we are reading from the console, we have something called the input stream. So whatever has to be given to the output stream goes as a string. That's why when you do print 5 is printed inside double quotes, and whatever is taken from the input stream is again taken as a string. So that is one implicit conversion which happens when you print things or when you read things. So because of that default behavior, that's why this is stored as a character, not as a number. Because if you think about it storage wise, then of course, the moment you have numbers, int, or in some languages, you explicitly define. So in R, we don't say int, float, all those things. R automatically, accommodates that for us. It figures out what kind of variable we are working with, and then based on that, it allots the required memory or required amount of resource to that variable. But in low level languages, you explicitly have to mention that, okay, if I am defining x equals 5, and if that is integer, I have to say that x is an integer by putting this int x equals 5. If I am defining this as a double or a floating point number, I have to explicitly say float x equals 5.0. Now in some newer languages, you have these provisions of int 32, int 64, int 128, and so on. What that does is, or in some cases you may also come across big int or long. What any or all of these keywords do is that they identify initially itself how much amount of memory space must be allotted to that variable. So int has a limit. You cannot go beyond that limit. So if you try to store a number larger than that, it will, so let's say, just for demonstration purposes, this is not the truth. Let's say int goes from -5 to 5. That is the limits of int. So the moment you try to store 6, so you say int x equals 6, what happens is int doesn't know what 6 is. So after 5, it will go back to -5. So even though you are inputting x equals 6, what you will get is x equals -5. Similarly, if you do x equals 7, you will get x equals -4. So that is a problem because that is unexpected behavior. So that is why if you give the user the freedom to enter different data types in different ways, so if the output stream could read numbers as numbers and differentiate between numbers and string, the problem that would have arisen is that, let's say, some student forgot to add spaces. Now, what I have mentioned is that I know within my program that this should be from 0 to 50, this should be from 0 to 100, each of these should be from 0 to 10. And even the roll number is a 4-digit number. That's something that my program knows. And maybe I have established if-else conditions to check for that. So let's say a user makes a mistake like this. So instead of giving separations, just puts everything together. Then 43, 92. Now this whole thing, I'll assume that we are storing roll numbers as numbers as well. So we're storing roll numbers as integers. A roll number, maybe the school has, or forget about the school. If roll number has to be a 4-digit number, the upper limit is 9999. So the roll number can't be bigger than that. So if a student makes a mistake like this whole thing, when the computer is reading it, the computer will try to store this in the roll number variable, but there will be an overflow because I've only allotted the memory size to contain 4-digit numbers. Second problem is that due to this kind of a mistake, my input is not completed because the comma separated input that I had asked for required name, then 1 number to denote your roll number, 5 more numbers to denote your assignment marks, then another number for the mid semester, another number for the end semester. Without any spaces, the computer has only received this. So it's still expecting 7 more inputs. So even though the user will keep pressing enter, 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 the end of file has not been reached. So there's an overflow problem and there is a processing problem for the input. So that's why it's better and more economical to treat the entire line of console input as one data type. So that's why the full input will be treated as a string. You read in that string and then you can do manipulations. So, because if the computer were to check every time for this overflow issues, you will, first of all, you will have to write a more complicated program. And even with that complicated program, the program will take a lot of time to run for, just a simple task. So a lot of economy is achieved by actually codifying what you want to do with the string and manipulate the string instead of manipulating the input itself. I mean, of course, at the end of the day, you are manipulating the input, but after having read in the full thing. So I hope that clarifies why things are read in as strings, and also the example demonstrates to you that after we have read things in as strings, how to utilize the split function.
Please.
Okay, so there's one more function that was discussed in this week's lecture, so I'll just briefly mention that and we can probably end the discussion. So what we had was this nchar or nchar, depending on how you want to pronounce it. The hint is in the name itself, so nchar just gives you the number of characters. So it will take a character vector as an argument and give you the number of characters. So we have so many variables defined, we won't define anything new. So instead of defining anything new, what we'll do is just operate this on each of these variables and see what we get. So A was just a character vector or a single string containing this hello world. So it contains 11 characters. You can count and verify. So 5 letters in the word hello, 5 letters in the word world, and 1 space in between. We do this for B. So it returns a weird value, integer 0. That means nothing is stored there. So that's why it's saying integer 0. There are no characters in null. Now in our date. So again, if you go counting the full thing, so there's 3, then a space 4, then 4, that's 8, 11, and then similarly, so 13, 14, then 16, 17, 19, 20, and then 4 more, 2022. So if you do it for days, so days was a vector. There's a collection, so there are 3 different values inside it. So it will return the number of characters in each of them. So Monday has 6 letters or 6 characters, Tuesday has 7 characters, Friday also has 6 characters. If we do this for SHW. So again, this may look deceptive because you see spaces in between, but this is still a single string. So it's not double quotes 10, then space double quotes 8, then double quotes 7. No. 10 space 8 space 7 space 9 space 8. Everything is inside the same double quotes. If you give it to x, it will just return 1, 1, 1, 1, 1, 1. Because they are single numbers. So if you convert numbers into characters, you get single characters. So basically that's what you are getting. So you can do this for var4 as well. And lastly, you can do this for instead of var1, let's do var2, 121 characters. Now, just like we demonstrated the utility of the split function, the utility of the nchar function is that in some programs, again, a lot comes down to managing your resources. So you can instruct the user not to, or to enter certain information within a limited number of characters. So the homework marks that we had encountered, it's possible that someone could have entered 10.0, someone could have entered 9.00. So if you instruct the user that, okay, just enter at most 2 characters for that, then you can check if the user is, adhering to your instructions or not. So you can put a if nchar is equal to, for this thing, if it is equal to 2, then you proceed with the program. If not, you immediately print an error message. You can tell the user that invalid input or something like this. So that is about making the program more interactive using these string manipulation functions. And of course, at the end, you, in like any other programming language, you also have the provision to convert the cases. So you can put everything to lower cases, and you can also put everything to uppercase. Okay, so stop presenting. And if there are no more questions, then maybe we can end the discussion here. Okay, then I'll see you guys on next Saturday. Goodbye.